These are solutions to a few more of the problems from homework 5.4 day 1. First problem, number 39, that we're going to look at is 5 to the negative second equals 0.2. We can solve this in more than one way. One way to do it would be to use one-to-one properties. So I can think of 5 to the negative t over 2 is equal to 0.2 is actually 1/5, which is 5 to the negative first. And now we can equate exponents using one-to-one properties. So we'd have negative t over 2 is equal to negative 1. And multiplying both sides by negative 2, we'd have t is equal to 2. The other way we could solve this problem, if you don't recognize that you can rewrite 0.2 as a power of 5, is you can rewrite as a log. Okay, so let's try that. Let's start again. And this time we'll rewrite it as a logarithmic equation. So I have 5 to the negative t over 2 is equal to 0.2. And now I can rewrite this saying the log is the exponent. So I can do negative t over 2 is equal to log base 5 of 0.2. And then multiply both sides by negative 2. So I'd get t equals negative 2 log base 5 of 0.2. And if you punch that into your calculator, you will get 2. In the next problem, we have an exponential equation. We need to begin by isolating the exponential portion. So we'll divide both sides by 3. And we'll have 5 to the x minus 1 equals 7. This one we're going to rewrite in logarithmic form. So we can say this is x minus 1 equals log base 5 of 7. Remember, the log is the exponent. Isolating x, we would add 1 to both sides. So x is equal to log base 5 of 7 plus 1. And if we want a decimal approximation, you could enter that in your calculator and you get that's about 2.209. The next problem is also an exponential equation. We begin by isolating the exponential portion, so divide both sides by 100. So you have e to the negative x is equal to 300 over 500, which I'm going to simplify as 3/5. This one you can rewrite in exponential form, or you can take the natural log of both sides. So in this one, I'll take the natural log of both sides. So ln of e to the negative x equals ln of 3/5. And ln of e, they undo each other, leaving us with negative x is equal to the natural log of 3/5. And then multiplying both sides by negative 1. So x is equal to the opposite of the natural log of 3/5. If you enter that in your calculator, you get approximately 0.511. Oops. The next problem we're asked to solve in two ways. One is using a graphing utility, which is your calculator, or solving it algebraically. So if we were going to use our calculator, we have to solve this by graphing. So you can let f1 of x be equal to the left side of the equation, so 3e to the 3x over 2, and let f2 of x equal 962. When you graph those, you'll have to adjust the window in order so that you can see the graph. So the window that I used was x min was 0, x max I set at 10, y min I set to be 0, y max I set to be 1000 because I know I have to go at least up to 962, and the y scale I set that to be 500. You can do what you would like. And then the graph that you're going to get is going to be something like this for the exponential portion, and then the horizontal line, which would be 962. And I guess this value would be 3. And then the point of intersection, when you graph this, is going to be 3.847, comma 962. So the solution to this problem is x is equal to 3.847. Okay, let's also solve this problem algebraically. So I'll do that here. So we have 3e to the 3x over 2 equals 962. First thing we want to do is isolate the exponential. So we have e to the 3x over 2 equals 962 thirds. Then we can rewrite this in logarithmic form. So 3x over 2 is equal to the natural log of 962 over 3. Remember, the log is the exponent. And now we want to get x by itself, so we can multiply both sides of the equation by 2/3. So I'll do that. So times 2/3 times 2/3. So x is equal to 2/3 times the natural log of 962 over 3. And if we enter that into our calculator, we'll get the same thing as when we graph, which is 3.847 about. The last problem is the natural log of 2x equals 2.4. This is problem 79. So to undo the natural log, we can write this in exponential form, or you can exponentiate both sides. I'll exponentiate both sides, so that with the base e, so e to the ln 2x means that 2x is the left side equals e to the 2.4. To isolate x, divide both sides by 2. So x is equal to e to the 2.4 over 2. And if you want a decimal approximation for this, you could enter that in your calculator and you get about 5.512.